Very good morning to one and all. This class, let us discuss about Thevenin's theorem. The given circuit, we have to calculate the current I0 through the 2 ohm resistor in the circuit. It is given very clearly that the current flowing through the 2 ohm resistance is I0. This right side, I have drawn the equivalent circuit of the Thevenin's theorem. So, what is the Thevenin's theorem? A complex network can be converted into a simplified Thevenin's equivalent circuit, which I have mentioned in the slide. The voltage source is called as Thevenin. The resistance is called as Thevenin, and another resistance is called as load resistance. So the complex circuit can be converted into a simplified equivalent circuit. What is the procedure for Thevenin? Thevenin with Thevenin's resistance. To calculate the Thevenin's resistance, the procedure is remove the load resistance, measure the resistance across the removed load resistance point. That is called as Thevenin's resistance. What is RL? RL is nothing but load resistance. In the given circuit, directly you can observe the value of the RL and you can substitute in the equivalent circuit. For example, the given circuit, it is given as calculate the current I0 through the 2 ohm resistor. It is understood that 2 ohm resistance is called as load resistance. Or else in some networks that will be mentioned clearly like this. The value of RL will be written like this, RL. So the value of RL you can take from the given circuit and you can substitute here. So RL is easy, no calculation at all. Thevenin is, I will repeat the procedure. Remove the load resistance, measure the resistance across the removed load resistance point. When you are measuring the load resistance, when you are measuring the Thevenin's resistance across the removed load resistance point, you have to remove all the sources. All the sources should be eliminated from the given circuit. Voltage source means it has to short, current source means it has to open. That is the thumb rule. So calculate the value of Thevenin's resistance and substitute here. It's also over. The last one is Thevenin's voltage. How do you measure the Thevenin's voltage? The procedure is remove the load resistance and measure the voltage across the removed load resistance point. In this case, we have to keep the sources as it is. So, for example, in the given circuit, there are two sources. Both are voltage sources. Both are independent DC voltage sources. Again, I am repeating this. Theorems, all the theorems on KCL, KVL is applicable for both the AC as well as DC. This circuit we have taken only DC. So we have to measure the voltage across the removed load resistance point by keeping the voltages or keeping the sources in the circuit as it is in the given problem, and voltage across the removed load resistance point. That voltage is called as Thevenin. After substituting all the values of Thevenin and Thevenin and RL, you can easily calculate the task. What is the task? Calculate the current flowing through the load resistance. Here RL is equal to 2 ohm. This value is 2 ohm. So assume that you have calculated the Thevenin. Assume that you have calculated the value of Thevenin. So easily you can calculate the current flowing through the 2 ohm. So unless you draw this equivalent circuit, this will not come under the Thevenin's theorem, right? So for the using Thevenin's theorem, the question is given very clearly using Thevenin's theorem. So you must draw this equivalent circuit. This equivalent circuit is very important, right? Now let us see this. The circuit is Thevenin or Thevenin. You have to calculate it. As I said, first Thevenin. Thevenin, I said the voltage source has to short. If it is a current source, the current source has to open. But the given circuit, only two voltage sources are there. Both are short. So now look at the resistances 1 ohm and 3 ohm. Both are parallel. So we can simplify and we can calculate the value of Thevenin. In the same way, you can calculate the value of Thevenin. Open the load resistance, measure the voltage across the removed load resistance point, which I have mentioned here, A and B. That voltage is called as Thevenin. Again, this is also a very simple circuit in which two voltage sources, two resistances are connected. Easily you can calculate the value of Thevenin. The values are, as I have mentioned, 1 and 3 are parallel, so 0.75 is Thevenin's resistance, and Thevenin is 2.25. After computation of all the two values, just substitute here the value of Thevenin and substitute here value of Thevenin. This one is observation from the given circuit. 2 ohm is directly taken from the given circuit. So now a very simple circuit. This circuit is called as Thevenin's equivalent circuit. The complex circuit is redrawn as a simplified Thevenin's equivalent circuit. That is the beauty of the Thevenin's theorem. So with that, you can easily calculate the value of I naught. That I naught is nothing but voltage divided by the resistance. So 2.25 divided by addition of these two resistances. Because the simplified Thevenin's equivalent circuit in which the resistance is addition of these two. So voltage divided by resistance will be the current. 0.8182 is the answer. Okay, we'll meet in the next. Thank you.